Hi everyone, in this video we're going to solve the January 2023 23 M1 paper. Now this is going to be a year-wise walkthrough and we're going to solve each question from this paper with as much detail as we can. So let's start. This is question 1. Now in question 1 it says that a train travels along a straight horizontal track between two stations A and B, and the train starts from rest. That means the initial velocities were 0, so u is 0, and station A, and accelerates uniformly for t seconds until it reaches to a speed of 20. That means initial velocity was 0, final velocity is 20, and the total time taken is capital T over here. This is your final velocity. The train travels at a constant speed of 20 for the rest of the 3 minutes before decelerating uniformly until it comes to rest at a station B. The magnitude of acceleration of the train is twice the magnitude of the deceleration. Now, this statement over here that acceleration was twice than deceleration, that means that acceleration section of the graph will be more steeper than the deceleration section of the graph. And again after this it says that on the axis below, sketch a speed time graph to illustrate the motion of the train as it moves from station A to station B. Now this will not have any negative axis because this is a speed time graph, right? Not a velocity time graph. So as it's just a sketch over here, I don't think we can add much to this diagram. But then again, let's try. We'll first try to draw that first case for acceleration, where the train accelerates from 0 meters per second to 20 meters per second in t seconds. And the final velocity reached after this was actually 20 meters per second. And then again it continued this time, like this speed, for the rest of the 3 minutes, which is like what, 3 into 60, that's 180 seconds. So this like speed of 20 minutes, so 20 meters per second was continued for the rest of the 180 seconds, and then again after that it obviously decelerate. Now remember that the rate of your acceleration was twice than that of your deceleration, so this line should be more inclined than this decelerating line, right? Okay, and now we have to label the x-axis over here. The accelerating time was t seconds. In that case it's going to be t, and over here constant time was 180 seconds, but as you are drawing this over on the graph, so it's going to be 180 plus t, and the total time is going to be what, 180 plus t, right? Okay, another thing over here to remember is that if accelerating took t seconds and decelerating was like twice less than that, that means obviously decelerating will take 2 more times of that capital T. Right? Think of it like this, that acceleration and deceleration, you want to make them both equal. Acceleration is already twice, right? So in order to make it equal to deceleration, you need to multiply 2 on the right hand side with the side for deceleration. And then again, if the time taken for acceleration was capital T, the time taken for deceleration would be twice t. In that case, this section has 2 t's over there. So what is the final value? Up to this, it was already 180 plus t. Adding this with another 2t will get you 180 plus 3t. That means at the very end, this portion you're going to write 180 plus 3t. 3t. Okay. Now after this, that was it for the graph. We're done with that. Well, let's move on to part B, where it says that stations A and B are 4.8 kilometers apart. We need to find out the value for t using this information, which we can clearly understand. The area under the graph will give you the value for distance, and that can be compared with the time capital T. Okay, now over here, this is an entirely trapezium, where the denominator was, sorry, what the base over here is 180 plus 3t, and this section is going to be just 180, right? And height is obviously 24, so we can directly write it down over here, is that AB distance is going to be 4800, because obviously we have to convert that distance into meters. So we are going to get half multiplied with 180 plus 3t plus 180, and height was 24. This is equals to 4800. After that, if you cut this together, you get 12 on this side. 180 plus 180 will be 360. So you get 360 plus 3t, and you take this to the other hand side. So like 12 to the other hand side is going to be 4800 over 12. So 4800 over 12 is also 400. So we can write t is actually 400 minus 360 divided by 3. In that case, 400 minus 360 by 3 is actually 40 over 3. In that case, the time taken for the constant, for the acceleration was 40 by 3 seconds, right? Now in the question, it was never asked that you need to keep your answer to three significant figures or not, so you can just keep it in fractions. That's totally fine. And for part C, it says that find the acceleration of the train during the first t seconds of its motion. Now they wanted to find out the acceleration. That can be easily calculated in this page only. For part C, I already know the time, final velocity, initial velocity. I just have to use this equation. V is equals to u minus, sorry, V minus u over t, which is 20 minus 0 over 40 over 3, right? That is just it. So 20 divided by 40 by 3, and you are going to get 1.5 meter per second square, right? That was a value for your acceleration over here. So with this, our question 1 entirely ends. Wait 1 minute. Final velocity was, sorry, 1 minute. No, wait. Oh, wait, sorry. I actually made a mistake. Over here, this was actually 20. I saw it as 24 for some reason. In that case, this becomes 10, which is going to be 10 over here. So 4800 divided by 10 is actually 480. So 480 minus 360 divided by 3 is actually 40 seconds, not just 40 by 3. Sorry for that. So if this is 40 seconds, in that case over here also, it will be 20 by 40, which is going to be 0.5 meter per second square, right? Yeah, sorry, I read the question wrong in the first part. Yeah, this is it, the graph and part B and C. Right, this is it for question 1. We'll move on to question 2. For question 2, it says that two particles A and B are moving in a straight line in opposite directions towards each other on a smooth horizontal surface when they collide directly. Particle A has mass 3m and B has mass m. Immediately before collision, both particles have a speed of 1.5, and immediately after collision, the directions of A is unchanged and the difference between the speed of A and B is 1. Okay, we need to find out the speed of A immediately after the collision and B. Let's just first draw a diagram that how the particles were traveling and would be travel after the collision over here or before the collision. So it was not stated that if after the collision they are traveling together, right? It was stated that after collision they have different speeds, right? It was stated the difference between the speed of A and B is 1 meters per second, but we do not know that exactly which ones is going to be greater than 1 or less than 1. 1 minute. The direction of motion of A is unchanged and the difference between the speed of A and B, right? In that case, it actually indicates, like if you focus on this statement only, the difference between the speeds of A and B, this indicates that the speed of A minus speed of B is actually 1, right? This is how the statement is arranged. So let's just first draw the diagram first clearly. This is for before collision, and this portion is for after collision. Okay. Now for before collision, the mass was, I think, what? The mass was 3m over here. This is particle A, and the mass was m for particle B. This is again 3m for particle A and m for particle B. Okay, and this over here is actually traveling in this direction, and they were all traveling in opposite directions before collision, and after collision A was traveling in this direction, was like the particle A did not change its direction during the motion, which means that particle B would have to change its direction now. So particle B would now travel towards the right, and this velocity was 1.5. They were all moving with same velocity before collision. And for the after collision, let's just simplify this statement. I'm going to consider the velocity for particle B as x. In that case, this will be VB plus 1, which is just going to be x plus 1, right? I'm considering the velocity of particle B as x. So which makes it as, this is going to be x meters per second, and the speed of particle A is going to be 1 more than this data. So x plus 1 meters per second. Now we need to find out the velocity of the speed of A immediately after the collision, right? And then we need to find out the speed of B after the collision. Okay. Yeah, then I think since they're asking you to find out the value for speed of particle A first, I think it would be better if I assume that particle A has a speed of x, right? If this has a speed of x, in that case, VB would be just x minus 1, right? So just keep it like this. So this is x and this is going to be x minus 1. Okay. Now we will start with the calculations. Now over the calculations, we can see that these are sum of total momentum before collision and total momentum after collision. Now over here, every particle was like most of the particle moving towards right, only that initial velocity of particle B was moving towards left, right? Which means that this will be positive, this will be negative, this will be positive, this will be positive, because I'm considering direction towards right as positive, which makes everything positive other than the initial section for particle B. So for this part again, we have this 3m 1.5 and then minus m 1.5 is equals to, then you get 3m x plus mx minus 1, right? Which is again going to be what? 1.5 multiplied with 3 is 4.5. Over here, this is going to be 3mx plus mx minus mx minus m, right? Now over here, if you take all the m's together, which is going to be 4.5m minus 1.5m, and also this m to the left hand side is going to be positive m, and 3mx plus mx is going to be 4mx. So in that case, x will be 4.5 minus 1.5 plus 1, this is 4m, and if you took that 4m on the other hand side, this is going to be divided by 4m, so the value for x turns out to be 1 meters per second, right? Wait. So the value for x turns out to be 1. In that case, the value for b would be, no, I think I'm making some mistake, is unchanged, and the difference between the speed of A and speed of B is 1 meters per second. Speed of A and the speed of B is 1 meters per second. Right. Minus 1.5. But I think my assumption over here was wrong, that I assumed that the speed of A and speed of B, like over here it says that the difference between the speed of A and speed of B is 1 meters per second. So I should have rearranged the equation in the other way around, because in this way, if the velocity for A is 1, according to my assumption, B would be 1 minus 1, 0, right? But that was not the case. B was not stationary. B was in motion. So I have to think of the other difference, which is going to be VB minus VA equals to 1, which makes it, I'm going to consider the value for VB as x now. So this is going to be, VA is going to be x minus 1, right? Yeah. So in that case, I will change out the layouts over here. This is going to be now x minus 1 and this is going to be x in this case, right? B has a greater speed than the particle A. So in that case, there will be few changes over here again. We're going to have x minus 1 over here and just mx over here. So which makes it 3mx minus 3m plus mx. On the right hand side, we still get that 4mx, but with this 3m, we are going to have over here plus 3m. So now you have 4 plus 3 minus 1.5, which gives you 5.5 on this side. So that 5.5 over 4 will actually make it 1.375. 1 minute. I'm maybe making some other mistake. 3mx minus 3m. Oh, in that case again, I'm calculating the value for B again, right? Really sorry, 1 minute. I think I would just have to make the value for VA as x, right? So VB will be x equals to 1. In that case, VB will be eventually x plus 1, right? That way I can calculate the value for A first and then use that I can calculate the value for B. So in that way, this is going to be x plus m, x plus 1, and this is going to be mx plus m. And if you take that mx to the other hand side, this is going to be minus m, and on this part we're going to get 4mx. So 4.5 plus 1.5 minus 1, you get 2 on the numerator. So 2 over 4 is when you get half in meters per second. Now this was the velocity of particle A. You just have to add 1 with this to get the final velocity of particle B. So at that part, for part 2 I think, for part A part 2, velocity of particle B is just going to be what? Half plus 1, that is going to be 3 by 2 meters per second, right? No other working has to be done for the second part. I hope this part A12 was clear for all of you. Now it says that find in terms of m the magnitude of the impulse exerted on B in the collision. Okay, so since it was exerted on B, we're only going to focus on the velocities of particles on B. So that means in particle B, this was particle B. Particle B originally was traveling towards this. Initial velocity was 1.5 meters per second, and final velocity was in the opposite direction but with same magnitude, 1.5 meters per second. And on part B, during impulse, during collision, there was a force of this Newton exerted on B towards left, right? Now over here, as you can see, according to my assumption, I considered this as negative and this as positive, right? Which means now impulse will actually be mv minus mu, which is mass is just m, and v is 1.5 minus m. Initial velocity was again negative 1.5, right? So minus minus it becomes positive. So you have 1.5 m plus 1.5 m. So if you get 1.5 plus 1.5, that is 3 m over here, right? So this is 3 m kg meters per second. This is the impulse exerted on particle B during the collision by particle A. Okay, so this was it for question 1. So question 2, we'll now move on to question 3. I'll just zoom out so that you guys can have a look for entire maths. Okay. This is question 3. It says that a particle P is moving with constant acceleration of minus 4i plus j, and at time t equals to 0, P has a velocity of 14i minus 5j. You need to find out the value for speed of P at time t equals to 2 seconds. At first, this was the value for acceleration, right? And this was the initial velocity over here. Using the time, we can find out the value for final velocity. Sorry, for part A, we're going to use the equation v is equals to u plus at. So u was 14i minus 5j plus acceleration was minus 4i plus j. this will be multiplied with 2. So you get 14 minus 4 multiplied with 2i, right? And then you get minus 5, this was 1, right? So you get eventually 2 plus 2j, that is eventually 14 minus 8 is actually 6. And over here you're going to get minus 3j. Now this was the velocity, final velocity after 2 seconds, and they were asking you to find out the speed. That means you just have to find out the magnitude for this velocity. So which is going to be 6 square plus minus 3 square, everything inside a root. That is 3 root 5. Yeah, you can just write 3 root 5, that's fine. So I'll just write the speed of this particle at 2 seconds is 3 root 5. I'm so sorry. 3 root 5 meters per second. Okay. Now this was it for part A. For part B, it says that the size of angle between the direction of I means positive x-axis, and the direction of motion of particle at time t equals to 2 seconds. That means you basically have to find out the angle. I already know the velocity of the particle at time t equals to 2 seconds was, this 6i minus 3j, right? And now I have to find out what angle it was creating with the positive x-axis. Vector direction I means positive x-axis, so I'll just draw out the, right, 6 positive 3, so positive 6 axis, and minus 3 means it will be over here. So right, this is going to be 6 and this is 3, and we are going to find out this theta over here because they were also asking to find out the angle it was making with this positive I-axis, right? So it's just going to be what? Opposite over adjacent, 3 over 6. So you can write theta is actually tan inverse 3 over 6, which is going to be tan inverse 3 over 6. So that is 25, so 26.565. So I'll just approximately write 26.6 degree. That is the final answer. Okay. And then lastly, it says that at t equals to capital T seconds, P is moving with the direction of this vector, and we need to find out the value of capital T. Now again, over here, this time has changed this time, right? So I'm going to find out a new value for the final velocity using this capital T. So it will be, for example, initial velocity was 14i, just let me go back, 14i minus 5 and minus 4 plus j, okay. 14i minus 5j, this was your initial velocity. Acceleration was minus 4i plus j, this was your value for acceleration. Now we need to find out the final velocity when t is equals to capital T, right? When t is equals to capital T, in that case we're going to have 14i minus 5j, and then you have minus 4i plus j, that will be capital T, right? After this, you're just going to add these values, 14 minus 4 capital T I, these are the coordinates for I coefficients, and for j it's going to be T minus 5 j coefficients, right? And it was also stated in your question that these final velocity was actually in the direction of a certain vector, and that vector was 2i minus 3j, okay? So this final velocity, I'll just write this as final velocity 2, okay? This final velocity 2 was actually in the direction, means they're all parallel, so 2i minus 3j. This second velocity, second final velocity was in the same direction to this vector. Now, if this is, they are like similar, or they are traveling in the same direction, which means they are parallel to each other, that means we can say that this vector 2 is equals to k constant, this 2 vector minus 3j. Now, why is there a K? Because over here, this parallel situationship is just a relationship between the two vectors, right? That is not an equation. In order to create a equation from a relationship, you have to have a constant K over here. Now, we can solve this equation to find out the value for T without solving the value for K. So, let's just do this. I'm going to write the value for V2, which was 14 minus 4 capital T I and plus T minus 5 J is equals to 2ki minus 3k J. Now over here I'll start comparing the I coordinates with the J coordinates. So the I coordinates separately and then the J coordinates separately. So for the I coordinates, you're going to get 14 minus 4t equals to 2k, and for the J coordinates, you're going to get t minus 5 is equals to minus 3k. So what I will do is that I'll make k the subject of this equation. So it will be 14 minus 4t divided by 2. This is your first equation. And from this part also I'll make k the subject of the equation. So this will be k is equals to t minus 5 divided by minus 3. This is your second equation. After this, I'll just substitute the first equation into the second equation. So I'll just write substitute 1 into 2. Now I just have what? K equals to k, which is going to be either 14 minus 4t divided by 2 is equals to t minus 5 is equals to minus 3. I'll just cross multiply it. So that will be 3 multiplied with 14 minus 4t and 2 with t minus 5, which is going to be 3 multiplied with 14. So 3 with 14 is actually 42. So this is 42 minus 12t and this is 2t minus 10. I'm going to take all the t's together. So 12t plus 2t is equals to 42 plus 10. So that is 14t and this is 52. 52 divided by 14 is actually 26 by 7. So over here the time taken for that particle to receive that same second time was this. Wait 1 minute. 14 into 3, right? 14 into 3 is 42 and this is 12. 2t and this is 10. Right, if I'm taking this over there and that over there, so 42. Wait 1 minute. Let me see if I'm creating any blunder over here. 14 minus 4t and it was t minus 5, right? And that was parallel to this vector minus 3. Oh yeah, sorry, this was minus 3 over here, right? Which will make it minus over here and plus over here. So at the end, this is going to be a minus and this is going to be minus, right? So now you're going to get what? 10 and this is going to be 32, right? This is 10t, sorry. This is 10t and this is 32. So then t will be 3.2 seconds, right? 32 over 10 is going to be 3.2 seconds, okay. Now this is how you're going to find out the value for that capital T when when that final velocity vector was parallel with the vector 2i minus 3j, right? This was your part C, I guess. Okay. So yeah, that is it for this vector maths. We'll move on to the next part. Okay, question 4. It says that there's a branch AB of 1.5 meter long rests horizontally in equilibrium with two supports. The two supports are at points C and D, where AC is 0.24 and DB is 0.36 as shown in figure 1. There is a force of 150 newtons acting vertically, is applied vertically upward at point P. So we are at point B and the branch is on the point of tilting about C. Always remember that if it is about to tilt from one point, that means the reaction force from the other point will be 0. In this case, it was about to tilt from point C. That means reaction force from point D will be 0 over here. These statements indicate that reaction force from D is going to be 0 Newton. And again, write a force of 225 Newton So when a force of 224 Newton is applied vertically downward at point B, the branch is on the point of tilting about point D, which means that this situation RC is going to be 0 Newton. And the branch is modeled as a non-uniform rod of weight W newtons. Non-uniform means that this time the weight will not act from the center of this length. It will act from any section. So the distance from point C to the center of mass is x meters, and we need to find out the value for weight and x. Okay, now there are two situations given, when it was about to tilt point C and when it was about to tilt point D. We have to draw two different diagrams, two different questions for these two scenarios. So let's start with this diagram first. Now this is the point when I'm assuming that that what was the force? 1 minute. That 150 force was acting vertically upward at point B. Okay. Let me draw all the forces. That 150 Newton at B. This was an upward force, so 150 newtons at point B. So from this case, there's a reaction force from D. This is RD. At this situation, RD was 0 Newton because it was about to tilt from point C. So RC was also there. RC has a value, but we do not know that yet. And there's a 150 Newton from this direction. There's a weight from any part acting over here. Weight is W newtons. But it was given that it was at point X, and this Cx distance was X meters. Right. Other than that, there were no other forces acting on this beam. So let's just try to make RC the RC the moment. We're going to take the moment from point C, and let's find out where, from which direction this object will actually move over here. So we're taking moment from point C, and in that case you have total moment clockwise is equals to total moment anti-clockwise, right? For total moment clockwise, only this weight was making the beam move in the clockwise direction, whereas this 150 Newton was making it in anti-clockwise direction. So now you have W x is equals to 150 multiplied with the what? Only 1.4 minus 0.24, right? That will be the length for that C and B. So 1.5 minus 0.24, that is 1.26. So which is 150 multiplied with 1.26, which is approximately 150, 1.26 is 189. Okay. Now remember, in part 1, they asked you to calculate the value for W. So what I will do is that I will make this equation subject as I'll make the x the subject of this equation. So it will be 189 divided by W. This is your first equation. Then I'll copy this diagram again and plot it for that other case when there was another downward force acting at point B. That force was maybe 225 newtons acting vertically downward at point B, and then it was about to tilt from point D. So let me just write down over here, this is 225 Newton at B, and there's a downward force acting on the particle. Another thing, this time they have a reaction force at D. The reaction force at C was 0, right? And there's a vertically downward force this time, which was 225 Newton. And again, you have this W Newton acting from this point X. But now I'm going to take the, your value for the moment. Like I'm going to take the moment from point B. So this time I need to find out the distance between RC and point C and D. That will be just what? 1.5 minus this 0.4 and this 0.36, which is going to be 1.5 minus 0.24 minus 0.36, and that is going to be 0.9. So in between point R and C, you have 0.9. I already know this much distance was x meters, right? So C xd over here is going to be 1.9, sorry, this is going to be 0.9 minus x over here. Okay, and yeah, that's it. We'll now start taking moment from point D. So moment from point D is sum of moment clockwise is equal to sum of moment anti-clockwise. For this sum of moment clockwise, you have this weight. So weight multiplied with that 0.9 minus x equals to your 225 multiplied with 0.36. So if you're going to multiply 225 with 0.36, you get 81. Yeah, right, 81. And in that case, I'm obviously not going to take w, make w the subject of this equation. So it's going to be 0.9 w. Wait, 0.9. Ah, yeah, right. I'll just try to make x the subject of this equation, right? So it's just going to be 0.9 minus x. And over here, this was 81 over w. And if I just keep x over here, so it's just going to be 0.9 minus 81 over w. This is your second equation. Now, in order to find out the value for your weight, I'll just substitute the two equations. The first equation was 189 divided by W. This was your first equation. And the second equation was 0.9 minus 81 over W. This is your second equation. I will substitute equation 1 into equation 2, which is going to be 189 divided by W and 0.9 minus 81 over W. Obviously, I have to do, or I can just take all the W's together. 189 W plus 81 W equals to 0.9, and 189 plus 81 is 270 equals to 0.9. In that case, W is actually 270 over 0.9. So this is 0.9 is actually 300. The weight of the beam was 300. Now using this W, I can easily find out the value for X in part 2, which is going to be for part 2, we can use the value for the first equation, which is 189 divided by 300, which is now 189 divided by 300 is 0.63, right? Now your center of gravity was actually situated 0.63 meters away from that point C, right? And they were only asked you to calculate that 0.63 in terms of point C with respect to point C. So that is what needed. Okay, they do not want to find out that at what situation this weight was coming from the entire length, right? They only wanted to find out the value for X. So that is it. Nothing else to work from this part. Okay, so we had done this, all these working, like only this section of the work was actually from part 1, and the next one was from part 2, right? And this part is actually like a more of a like a common part for both part 1 and 2. Okay, we could have used this for part 2 also, right? Yeah, this was it for question 4. So we'll move on to the next question. Okay, now over here it says that 3 points PQR are on a horizontal road where PQR is a straight line, and point Q is between P and R, with PQ is 6x and QR is 5x as shown in the diagram. A vehicle moves along the road from point PQ with constant acceleration. This one is extremely important, that the acceleration for the entire journey was not same, maybe only the acceleration for that point PQ was same. And again, it was stated that the particle was modeled as a, so the vehicle was modeled as a particle, and at time t equals to 0, the vehicle passes P with speed u, and at time t equals to 12, the vehicle passes Q with 2u seconds. So we need to show that x is actually equals to 3u. Okay, acceleration was not given, but we know that there was a constant acceleration for this journey, which indicates that equations of motions was actually available for this section, right? So in that case, for part A, we have initial velocity as u, final velocity as 2u, and time as 12 seconds. And yeah, distance over here was 6x, right? So we can easily use the equation s equals to v plus u over 2 multiplied with time. Distance over here is 6x. V plus u is going to be what? U plus 2u divided by 2 multiplied with 12. So you get 6 over here, right? And again over here from this 6, you can actually get 3u multiplied with 6. If you take this 6 to the right hand side, it's going to be divided, and finally you get x equals to 3u, right? This was in the question which you have to show. So we have clearly stated this, and that was all the working for part A. We'll move on to part B. It says that as the vehicle passes Q, the acceleration of the vehicle changes instantaneously to 1.5. That means for PQ, the acceleration was different, and for point Q to R, the acceleration would be now 1.5. Okay, and the vehicle continues to move with a constant acceleration of 1.5 and passes R with 3u, and we use the model to find out the value for u in this case. Okay, if the velocity over here is 3u and the final velocity, initial velocity over here was 2u, acceleration is 1.5, and we have the value for x, right? Now we know the value for x is 3u, so we can use this as a statement for the distance also. Okay, so let's start for that QR journey. For part E, we're only focused on QR section of the journey. So initial velocity is now 2u, final velocity is now 3u, acceleration is 1.5, and this time distance will be 5 3u, right? Because in the previous part we got the value for x as 3u. So this is going to be 15u. Now we can use the equation v square u square plus 2as, where v square is going to be 3u whole square. This is going to be 2u whole square plus 2 1.5 and then again 15u, right? So from this part you get 9u square, 4u square, and 1.5 into 2 into 15. So 1.5 into 15 into 2, sorry, 1.5 into 15 into 2 is actually going to be 45u. So if you take everything to the right hand, sorry, to the left hand side, 9 minus 4 is going to be 5u square plus 45 is equals to 0. So I'm just going to take u common. Sorry, I can also take 5 as a common factor, 5u as a common factor over here, which is going to be u plus 9. So one data would be 0 and the other would be minus 9, right? Wait 1 minute. Oh, wait, sorry. When you're taking that 45 to the right hand side, it will be negative, so you get positive 9. Now, obviously, u cannot be 0 over here. In that case, all the velocities would have been 0. So, 9 over here is a possible correct answer, right? U is 9 meters per second in that case, right? That is it for part B. We'll move on to part C. It says that find the distance the way traveled by the vehicle during the first 14 seconds after passing P. We know that for the first 12 seconds, it was only covering the distance of this 6x, right? And we just find out the distance traveled during this section only for the next 2 seconds over there, right? Okay, so let's first find out the value for the distance for the first 14 seconds. So for the first 12 seconds, and then again separately find out the distance for the next 2 seconds. Okay, so I'll just break down that 14 into 2 sections. For part C, 12 seconds plus 2 seconds. For this portion, it was in between PQ, and for this second, it was actually in between QR, right? Okay. Now, after this, for this particle distance of point PQ, we have the value for U as 9, right? I already know that for this 12 second, the distance was 6x. That is going to be 6 multiplied with 3u, because x was equals to 3u. U is 9. So this is going to be 6 multiplied with 3 multiplied with 9. So at the end, you get 6 with 3 with 9. So this is 162 meters, right, for the first 12 seconds. And for the rest of the 2 seconds, we're going to do the calculation as, since we want to find out the value for distance over here, right? And time is given to you, initial velocity was 2u, acceleration was 1.5. You can easily calculate that for the QR section. So I'm actually using the equation s equals to ut plus half at square. So over here initial velocity was 2u and u was 9. So we can write 2u t plus half at square, right? And again from this part we can write 2 multiplied with 9. Time was 2 seconds plus half. Acceleration was 1.5. Time was 2 square. And if you calculate all these values together, it's going to be 292 plus 0.5, 1.54. So you get 39 from this part. Right? In the next 2 seconds, it will travel 39 meter. In that case, the total distance is 162 plus 39. That's approximately 201 meter. That means in the first 14 seconds, the vehicle has traveled in total 201 meter for this entire section of the journey. Right? This is the total distance, 201 meter. Okay. Now this was it. This was the working for question 5. We'll now move on to question 6. Okay. Now for question 6, it says that a boat is pulled along a river at a constant speed by 2 ropes. As we can see, one is 500 Newton and one is exerting P newtons. They are both creating different angles. One is 40 and one is alpha. And the banks of the river are parallel and horizontal straight line. Okay. Tension in the first rope is 500, angle of 40 degree, and tension in the second rope is P newtons, angle of alpha. The resistance to motion of the boat as it moves through the water is a constant magnitude of 900. This is a backward force, and the boat is modeled as a particle. Ropes are light and extensible. We need to find out the value for alpha first, and then find out the value for P. Okay, so let's first draw the distributions plane, like horizontal plane and vertical plane. Okay, in that case over here you have 500 cos 40 degree, and in the upward direction you're going to have 500 sine 40, and then again in for that P force, right, you're going to have P sine, sorry, not sine, it was as it was creating angle with the horizontal, so it will be P cos alpha, and over here it's going to be P sine alpha, and in the backward direction there was a resistive force of 900 newtons, right? Let me check if I'm not wrong. Yeah, 900 newton. Now they wanted to find out the value for alpha first and then find you the value for P over there. So I'll first resolve the vertical forces. In the vertical forces, I'll just write it down over here, that resolving vertically, obviously we'll start with RF is equals to MA. It was not actually moving in any direction, right? Because it was somewhere stated in this that yeah, it was actually moving with constant speed. That means even if it was moving, the acceleration over here would still be 0. That means the right hand side of the equation for both vertical and horizontal is going to be 0 at anyways, right? Because constant speed indicates that acceleration is 0. Okay. So now from this part we can write that for that vertical plane you have this 500 sine 40 degree minus P sine alpha is equals to 0 from this part, as I want to find out the value for alpha. So I'll make P the subject of this equation. So it will be P 500 sine 40 degrees divided by sine alpha. That is your first equation. And then I'll try resolving the horizontal forces. Resolving horizontally. Now you have again RF equals to MA, where A would be 0, and you have this 900 was resistive force. So you'll have 500 cos 40 degree then plus P cos alpha minus 900 equals to 0, right? And again from here I'll try to make P the subject of this equation. So it will just be P 900 minus 500 cos 40 degree. This entire thing will be divided by cos alpha. Okay, this is your second equation now. I'll substitute the two equations together. So you have, I'll just do this, substitute 1 into 2, which will basically be P equals to P. As they were asking you to find out the value for alpha, that's why I took P the subject, so that in between the equation you'd still have alpha. So which will be now 500 sine 40 degree divided by sine alpha is equals to 900 minus 500 cos 40 degree divided by cos alpha. What will I'll do is that I'll cross multiply this very quickly, so that on the left hand side now you will have cos alpha over sine alpha, and this 900 minus 500 cos 40 degree will be divided by 500 sine 40 degree, which we can again clearly understand that cos over sine is tan, right? So this is tan alpha is equals to this entire fraction over here. Sorry, this entire fraction over here. So just copy it and paste it over here again, right? Similarly, if I want to calculate the value for alpha only, it will be just tan inverse and that fraction inside the bracket for angle, right? Okay. So that means alpha over here is going to be tan inverse 900 minus 500 cos 40 degree divided by 500 sine 40 degree, and that is approximately 58.13 degrees. So 58.13 degree. If the value for your alpha was this, then you can just input this value for alpha in any of the equation. I'll input this into equation 1. So for part 2, I think P would be 500 sine alpha was 58.13 divided by, sorry, it was 58.40 divided by sine 58.13, right? Okay. So you get 500 into sine 40 divided by sine 58.13. So you get 378 Newton. Yeah, 378 Newton. That is the value for your P over here that was acting on this boat. Wait, my 1 minute. 900 minus 500 cos alpha cos 40 degree divided by cos alpha, and 500 sine 40 divided by sine alpha, right? And yeah, 1 minute. No, the angle was, oh wait, sorry, right. You get tan for sine over cos, not cos over sine, right? So I actually made a blunder over here. I was thinking that cos over sine was tan, but it was actually sine over cos, right? So in that case, we would actually have to do cross multiply this, and it would be like this over here, like this. Sine of 500 sine 40 will be on the left hand side, and that 900 minus 500 cos 40 is equals to sine alpha over cos alpha, right? I'm really sorry. Now in that case, we're going to get tan on the left hand side again if you just mirror it or shift it over here, and from then again I'll just take this. This will be in the numerator, and this entire thing will be in the denominator, right? And it will be changed. This entire thing will be over here, right? Now if I calculate it, this is going to be tan inverse 500 sine 40 divided by 900 minus 500 sine 40. That will be 29. 500 sine 40. Wait, sorry. Cos 40, right? This is 31.87, right? Over here, you're going to get 31.87 degree. Now, using this 31.87, I'll just write it down over here. 31.87, that is 500 sine 40 divided by sine 31.87. Wait, 500 into sine 40, then sine 31.87, that is 608.7. So we can write 609 approximately, right? Because the question, I don't think, was asked to keep you answering one significant figure or two significant figure. No, they just asked to calculate the value for alpha and p, right? So yeah, both the answers are correct now. Okay. So yeah, this is how we are going to solve question 6. I hope question 6 was clear for all of you. We'll move on to question 7 quickly. Okay. Question 7 is about connected particles. So in question 7, we have this P and Q at the base of a lift. A simple lift operates by a vertical cable which is attached to the top of the lift, and the lift has a mass of m, and the box P is placed on the floor of lift, and P is placed directly on top of Q, and the cable is modeled as a light and extensible string, and air resistance is neglected. The tension in the cable is 42 by 5 mg, and the lift as it contends to move vertically upwards has an acceleration 2 over 5g. And we need to find out the value in terms of m, the combined masses of P and Q. Okay, in terms of m, the combined masses of P and Q. Wait 1 minute. The lift itself has a mass of m over here, and acceleration was given, tension was given, and combined masses of P and Q, right? Combined masses of P and Q means that they are not separately thinking P and Q of as two separate items. They're rather considered as one item over here. So in that case, I'll just remodify the diagram, and over here for P and Q, I'll consider their masses to be like capital M. Okay. So in the vertically downward directions, you have this mg, masses of lift, plus capital Mg, masses of the objects. In the upward direction, you have this tension 42 by 5 mg, and it was traveling in the upward direction, right, with an acceleration of 2 over 5 g acceleration. Okay. Now after this, what tension and then weights, other than that, no other forces are concerned over here. Now in this case, as the object was traveling in the upward direction, that means obviously the upward direction was actually like the upward forces were actually greater than the downward forces. So we can write that part A. For resolving upward in upward direction, we can now write that what T minus mg minus capital Mg is actually going to be m plus capital M A. T over here was 42 over 5 mg minus mg. So 42 by 5 or something. 42 by 5 mg, right? 42 by 5 mg, and the other one was 2 over 5 mg minus capital Mg, and this is going to be M. So A will actually be multiplied with small m and capital M. So this becomes, A was already G, right? So this is going to be 2 by 5 mg plus 2 by 5 capital Mg. So in that case, if I take all the capital Mg's together and small mg's together, so it will be 2 over 5 capital Mg plus Mg, and this is going to be 42 over 5 Mg minus Mg minus 2 over 5 Mg, right, which is going to be 2 over 5 plus 1 is 7 over 5, and this one will be 42 over 5 minus 1 minus 2 over 5, that is going to be exactly 7 small mg. We can clearly understand these will be cancelled out, and at the end capital M is actually going to be 7m divided by 7 over 5. So 7 divided by 7 over 5 is actually just 5. So this is 5 small m, right? The combined mass of particles P and Q in terms of small m. So over here the combined masses are just 5m, right? Masses for P and Q is capital M. Let me just write it down over here that P and Q, their combined masses were assumed to be capital M over here. Okay. That was it. After that, it was stated that during the motion of the lift, the force exerted on box P by box Q was this much, and using this model, find in terms of M the mass of box P. Okay. Now, since we're only focused on box P, let's just write the forces that are acting on box P. Right. On box P, there's a weight acting in the downward direction, which we do not know. Let's just consider this as MP. Okay, that was just confusing. I'll just consider that as WG over here, right? And in the upward direction, the force exerted by Q on P, which was 14 by 5 mg, right? This was the reaction force by Q on P. This was 14 by 5 mg, and as it was already inside the lift, so obviously it would still be accelerating at that 2 over 5 g. So in that case, now you have our resultant force equals to mass acceleration. Resultant force is going to be 14 over 5 mg minus wg is equals to w a, which is 2 over 5 g, right? At the end, I'll take all the w's together, which is going to be 2 over 5 wg plus wg and 14 over 5 mg. This is going to be what? 7 over 5 again. 7 over 5 Wg is equals to 14 over 5 mg. Obviously, as on both sides you have this gravitational field strength, it will get cancelled out. And for W, you are left out with 14 over 5 divided by 7 over 5. And with this, you have this mass included. So you have 14 over 5 with 7 over 5, that will be just 2. So weight of particle P is just 2m. That is just the weight of particle P, which is only 2m over here, right? Yeah, this is it. This was your particle P, right? Okay, after this, we are going to move on to part, yeah, that was it for question 7 then, right? Okay, then we'll move on to question 8. I think that is the last question of this paper. Okay, let's move to question 8. Now in question 8, it says that parcel of mass 2 kg is pulled up a rough inclined plane. Rough means obviously this time it has a friction, and it is going to be pulled up. So friction is going to act in the downward direction with constant force. Okay, a force of magnitude 18 Newton. Constant force means what? it has an acceleration now, right? I mean, it would have an acceleration, okay? At an angle of 40 degree to the plane, the line of angle this, okay? The plane is inclined at angle of 30 degree itself, and the parcel is modeled as a particle. Find out the acceleration of p over here, okay? So in that case, we'll first have to draw the planes. This is the horizontal plane, and this is the vertical plane, and this is the direction through which your weight will actually act. Okay. Now, okay, over here your weight was 2g, and this is 2g cos 30 degree, right? Because this was also 30 degree, and this will be 2g sine 30 degrees, and over here it's going to be reaction force. This 18 Newton will be divided into 18 cos 40, and it will be 18 sine 40 in the vertically upward force. And for that reaction, it will have, I mean, for that friction over here, it will have friction in this direction, okay? 1 minute. It does have friction, but nothing about friction was mentioned over here, right? The coefficient of friction over here was 0.3, right? It was mentioned. Coefficient of friction between the plane and the parcel was 0.3, right? In that case, we first need to find out the value for r. So we'll first start our working with resolving vertical forces. So in that case, for part A, resolving vertically, we are going to write resultant force equals to mass acceleration. So on the upward direction, you have this reaction force plus 18 sine 40 degree minus on the downward cases, you had this 2g cos 30 degrees is equals to 0, because acceleration was 0 in the vertical plane, right? And from there, we are going to write r as 2g cos 30 degrees minus 18 sine 40. Now, I'm not going to calculate it directly because it would not give you maybe a perfect answer. Let me just check. 9.8 into cos 30 minus 18 sine 40. Yeah, that is 5.4 at a continuous value, and we'll keep our reaction force like this. And after this, we'll start calculating friction, which is mu r. Mu was 0.3. This will be multiplied with 2g cos 30 degrees and 18 sine 40 degrees, right? After this, you have now 0.3 into 2 is 0.6 g cos 30 degrees, and this 0.3 with 18 is actually 5.4 sine 40 degrees. Okay, now then we'll move on to that resolving horizontal forces. There we had an acceleration, so we cannot write the right side of the equation as 0 down directly. So resolving horizontally, now you have reaction force equals to mass acceleration. So for that reaction force now, in the forward direction or in the upward direction, you have this 18 cos 40, and in the backward direction, you have this 2 sine 30 and friction. So we're going to write 18 cos 40 minus 2g sine 30 degree. Your reaction force, I mean, your friction was minus 0.6 g cos 30, and minus minus is going to be plus 5.4 sine 40 degree. This will be equals to mass acceleration, which is going to be ma, sorry, 2a. At this point, I can find out a directly, like whatever we have on this side. I'll copy this and divide it by the mass over here. So this entire thing, sorry, this entire thing divided by a mass of 2, and that would be 18 cos 40, sorry, 18 cos 40 minus 2 into 9.8 into sine 30 minus 0.6 into 9.8 into cos 30 plus 5.4, sorry, 5.4 into sine 40, and this entire thing divided by 2. Let me just check. 5.4 sine 40 then you have 0.6 9.8 cos 30, then minus 2g sine 30 and 18 cos 40, right? So you get 1.83 meters per second square. Over here, the object will be accelerating at approximately 1.83 meters per second square, like 1.183 over here. So we can write acceleration over here is 1.183 meter per second square. That is the value for acceleration with which the parcel was accelerating up the plane. Now after this was the working for part A. Let's move on to part B. For part B, it says that the points A and B lie on the line of the greatest slope, like that means on the plane, and they have a distance of 5 meter, and B is above A also, and particle B passes A with speed of 2 and in the direction of AB. Find the speed of particle P as it passes through B. Okay. I mean, at AB, they would still be accelerating at that same rate we calculated in part A, which was 1.184 meters per second. And after that, initial velocity was 5. So initial velocity was 2 and distance was 5. We need to find out the value for final velocity. We can easily calculate this. V square u square plus 2as, where u was 2 meters per second square plus 2 1.18 multiplied with that 5 and everything under a root, right? That will give you the value for your final velocity. So which is 2 square plus 2 into 1.18 into 5, and that would be equals to 3.97 meters per second. That means the velocity with which the particle would reach that point B will be 3.97 meters per second. Okay. Sorry. 3.97 meters per second. Okay, and after this, it says the force of 18 is removed at the instant P reaches B, and as a result, P comes to rest at point C. Determine whether P will remain at rest at C. You must show all stages of your clear working, okay? But we do not know where C was, right? Okay. I mean, after it reaches to point B, right? Yes, after it reaches to point B, that forward force was removed. That means only the external, downward forces were acting on the particle when it was at point B. And from that point, because of this external force, this 3.97 would then be actually a initial velocity for that section of the journey, right? And then we need to find out that we need to find out that if at point C, it will come to rest or not. Comes to rest at point P, okay? Whether it will remain, we need to understand that whether it will remain at point C or not. And then we need to show the working for in that case, okay? How can I show that? Wait, 1 minute. If I can find out the magnitude, I already know it was stated that at point P it comes to rest, right? But will it remain at rest or not? For that part, I can find out the value for. Oh, I can find out the value for acceleration and then identify if the acceleration is 0 at point C. In that case, all the forces become balanced, and maybe at point C, it will not travel actually any distance on that cases, right? So whatever happens after point P, we'll draw it over here. For point C, this was your base and this was your plane, and this is your object at point B. Okay, at point B, weight still acts downward 2g, and this was your vertical plane and horizontal plane. So for the vertical plane, you're going to have 2g cos 30 degree. This time the reaction force will only be equals to 2g cos 30 degree. That 18 Newton is not going to play any role because that is entirely removed from the scenario. And over here you have this 2g sine alpha and mu r, right, where r is actually equals to now what, 2g cos 30. In that case, friction this time is 0.32g cos 30 degree, which is basically 0.6g cos 30 degree, right? Again, using this friction, we can actually calculate the using this friction we can calculate the value for acceleration this time. This time resolving horizontally gives you resultant force equals to mass acceleration. So there's no forward force this time, only the backward forces are acting. So you have this negative 0.6 g cos 30 degree minus 2g sine 30 degree is equals to 2a. So you get the value for a as negative 0.6 g cos 30 degree minus 2g sine 30 degree. This entire thing will be divided by 2. So now you get minus 0.6 into 9.8 into cos 30, and then minus 2 into 9.8 into sine 30. This will be divided by 2. You get a value for negative acceleration, which is like 7.44. Now this indicates that at point C it would start decelerating, right? The acceleration is still not 0. If it is decelerating, that means obviously that P will not remain at rest. It will start sliding down the plane, right? Because of the deceleration. So we can write that as A is less than 0. So P will start decelerating down the plane. Okay. Yeah, so this is the working for your part C. If the acceleration was 0, then it would have meant that the object is at equilibrium because all the forces are 0, acceleration is 0. But this time, as the acceleration didn't came out to be 0, it was negative. It indicates it was decelerating and the object is now about to move down the plane over here. Yeah, okay, this is it. This was all the working for your questions from Jan 2023 Unit M1. And with this, our entire video ends also over here. So thank you for watching.